Good day, Professor. In this opportunity is the resolution data street and the course of vehicle engineering. They are students de Saguanaco Daniel, Morales Velázquez Jean-Pierre, Romero Torres Marco. I am Manuel Castro Frank. In this case, the evaluate in the car is the turning radius and Ackermann geometry and tests braking system. First, select a car. In this opportunity, the car is on Toyota Yaris 1.8 centimeter cubical. That the technical specification of the car in the first is dimensions and weight. The length is 4.410 meters. The width is 1.700 meters. The height is 1.475 meters. The front rail is 1.418. The rear track is 1.417. The ground clearance is 147. The gross weight is 1.500 kilograms. The net weight is 1 kilograms. The next specification is the engine and the bodyworks. In the engine, the type of the engine is 2NC FE. Number of cylinder is 4 cylinder on line. The power is 18.4 and 6,000. The torque is 12.3 to 4.400. The bodywork. The direction of the car is electronical assisted traction and pinion, or more now is TPS. The brake front is ventilated disc, and the brake rear is the drum brake. The suspension is the independent type MacPherson. Type of transmission is a mechanical 5 velocities.
In case is turning on radios, I can see observe a graphic is that to perform the measurements of the radius of rotation the vehicle, we first have to calculate the distance between the rear axle and there between the rear and top after we already have two. So then we will calculate, but for this we have to move the rudder to stop, um, so the two vehicle can take a turn and from the two we divide it by two to half the radius. In this case is through center, and then we calculate the midpoint between the top of the and the bottom. The point will be half the height and the base. And also something important to find with the alpha and beta angle separate with the vehicle with to stop, we draw and perpendicular to the side and there to turn the runner so the tire can move, and there we will be an angle that we will be alpha and beta, but you have to take into account that you have to form 90 degrees with respect to the turning right. Okay. Taking measures for the turning right. How we can observe in the picture, we have to take the respective calculation of the magnitude, and I can observe the picture 1, 2, 3, 4 is respect the measurement calculation for radius of turn.
Continue on the video. In this case, we have to calculate turn center here, specific the radio, the turn radio. To calculate the turning radio, we have to make the vehicle turn to maximum in circumference. Here, the wheels turn to maximum possible. Then the vehicle turn to maximum in circumference. Then we will have the diameter of the circumference. So we can find the turn radius seen in the picture here. So the diameter was here 7 meters 50 centimeters. So the radio here, the radio was 3 meters 775 meters.
My name is Daniel Mesa. In this moment I talk about the braking system. Well, first I need a half of the a different value. For example, the weight, a half of the in the data sheet is the weight of driver. This is the pounds, brake force, and initial velocity. I have to estimate this, okay, this value.
Well, first I have to calculate the deceleration. This is the dx equal the fx is a force divided by m. This is the weight, the total weight is weight of and weight of driver. To here in the with respect the force, this is working force times the gravity. I have to alternate the value, the 60.39 feet divided by second square. Then I have to calculate the stopping distance. This stopping distance is equal the initial velocity to square divided by 2 times force xt divided by m. This is equal the initial velocity to square divided 2 deceleration. Okay. The value is 2005.1 feet. Okay. Then I have to calculate the time to stop. Time to stop is equal the initial velocity divided by of the force xt divided m. This is the same the initial velocity divided the deceleration. I have to replace the value. The final value is 5.003 seconds. Then calculate the energy dissipated. The energy is equal to m divided 2 times the initial velocity to square minus the final velocity to square. I have to replace the value. For example, the total weight 2 is this. Into here, this is a gravity times this is the initial velocity. This is to here. This is initial velocity minus final velocity is equal 0. It's the same, no? So don't change the result. The result here is 248,600 feet times the pounds. Then I have to calculate the power dissipation. The power initial is force the braking times the initial velocity is equal to is 99,384 feet times pounds divided by second. Then I calculate the horsepower initial. This is power initial times the into here I have to convert this value in horsepower. I have to multiply the 1 divided by 500. This is the value design. No? To here it is equal to 180.7 horsepower. Then I calculate the average over the stop. The power is equal. This is the total weight divided by 2 times the gravity. Then I have to multiply the initial velocity to a square divided by this value is the time to stop. Okay, divided the time to stop is equal it's the same, no? In capture here I have to convert it to horsepower. Is 90.3 horsepower. To here can I observe the other calculate for stopping distance with the taking aerodynamic. Well, in this can I the stopping distance is equal to m divided by 2 times c times the logarithmic of the force Fb plus the c times the initial velocity to square divided by the Fb. This is a force. This force is a braking force to this. Okay, can I observe the c? The value is this. Okay, c is equal to 0.00935 feet times second to square divided the feet to square. Okay, the value to here this is 199.97 feet. Can also bet is quasi same with respect this stopping distance. It could be the same, but into here don't consider it of taking aerodynamic. Okay, can also bet this is a calculated with respect to the braking system. Thank you.